welcome to our first session of your Astronomy 114I course. And what I'd like to do today is go ahead and just give you a nice general feel for what we're going to study for the rest of the semester. And so I'm going to talk about astronomy, and that is basically our study of our universe. And the rest of the time you're going to actually see, instead of me, you're going to get to see some slides, and we're actually going to look at my vacation slides, or at least the vacation that I would like to take throughout the universe. And so if I define what the cosmos is, basically cosmos is all there is, all there ever will be, or ever was. And so like I said, guys, we're going to do my vacation slides, or at least the vacation I would like to take through the universe. So let's go ahead and get started. And probably the main thing that you guys would realize if you went outside and looked up is you're going to see the sun. It's about 93 million miles away from us, so we're going to certainly talk about its properties as a star. But more importantly, we're also going to talk about its property as what it does for our solar system. And so I've got a few pictures of the sun taken from the Earth. You see a picture of the setting sun right here. And I want you to notice the colors. Also want you to notice how much atmosphere it's going through, because we'll talk about what that atmosphere does to our seeing conditions as we go ahead and talk a little bit about planets and stars and looking out at the rest of the universe. Now here's a picture of the sun, and I think you'll notice there's a little weird sunspot right there, and that's actually the International Space Station. And so when they're taking the picture of the sun here, the International Space Station happened to be right in front of it, so they captured it, which I thought was a really kind of cool picture there. This is the sun taken from looking out from the Earth, and you can see that it's nothing more than a big ball of gas. It's a bubbling gas. Think of the surface of boiling water, and that's what the surface of our sun looks like. Just several pictures there of the sun that we're going to talk about. Remember, that provides all of our energy. We wouldn't exist if it wasn't for the energy from the sun. Just to give you kind of an idea of the size of the sun, we can take about 100 Earths and put them across the surface of the sun. So it's much, much bigger than what we are. So looking at some sunspots on the sun. Remember I said that it looked like a boiling surface of water? Well, now we're real close to the surface of the sun, and you can kind of see that or imagine those granulars that are boiling. So it kind of gives you a feel for what the sun looks like. And the characteristics of the sun, we're looking at a magnetic field here on the sun that we'll go ahead and talk a little bit more and find out, even though that thing is 93 million miles away from us, how does it influence what happens here on the Earth? Not only with our weather, but just in general. Okay, so what you see here is a little bit different picture of the sun. You've got an X-ray picture of the sun here. And in the top and in the lower left, you have what are called coronal holes. You have material that comes streaming out of the sun. We'll talk about why later on, but essentially 24 hours later, that'll go ahead and run into the Earth, and when it does, we'll have static and noise, things like that, in some of our electronic devices. Now let's head out to our solar system. We have 8 planets. For those of you that are a little bit older, you'll remember that at one time we had 9. Well, we now go back down to 8. Pluto is no longer a planet. When we talk about planets, we'll talk about why Pluto has been demoted. But you can see the Earth there, and these are basically the inner planets, or the terrestrial planets. You've got Earth, and then you've got Venus sitting on the side, which is a little bit smaller than the Earth. And then you have Mars, you have Mercury, and then you've got, actually right now you do have Pluto in there, but just as a comparison. And then let's go ahead and go up to the gas giants. And so you still have the planets that we just talked about in terms of terrestrial planets down there. Notice their scale is much smaller now because we now have the gas giants, which is Jupiter, Saturn, Uranus, and Neptune. And now we're going to put them relative to the sun. And at this scale, we even have a hard time seeing the Earth at all there. You still see Jupiter and Saturn pretty well, and Uranus and Neptune, but those little bitty dots that you see in the lower right are the planets that we talk about as being terrestrial planets. Just another picture of the sun. In this case, though, you look at the upper right, and you've got Mercury going in transit across the sun. So basically, on Mercury's, it would be like an eclipse. Now, Mercury looks a lot like the backside of the moon, and that's a planet that's closest to the sun. It's just another picture of Mercury. And you are seeing then both Mercury and Venus. Venus is going to be the top one. Mercury is the lower one on the bottom. kind of right there in the center to give you an idea of what they look like. So we can go outside at times, see then both Mercury and Venus. Now here's a picture of Venus and the moon in front of radio telescopes. And one of the sections that we'll talk about in class will be what those radio telescopes are and how we obtain information from out there in the cosmos. Now this is a picture of Venus during a phase of Venus when we're looking at it about a quarter. And we will be able to see Venus during the day, and when we do, Venus is extremely bright, one of the brighter planets, because a lot of the light that goes into it gets bounced off of it because Venus is covered with a very thick cloud covering. In fact, we can't see the surface of Venus. Now I can if I take it with a radar map, so this is taken with radar, and it will penetrate then the clouds. And you're looking at Venus itself. Venus is mostly real flat with some areas that are uplifted, which are the areas that are a little bit lighter, and then the areas that are a little bit darker then are a lower elevation. So when we talk about Venus, we'll find out what those really mean. And at one time, Venus was assumed to be our sister planet, and that, hey, chances are there might be possibilities of life there. Well, when we get to Venus, we'll talk about, is that a realistic thought or not? Just looking at more of the surface of Venus, very low, gentle rolling hills. Definitely unlike what the Earth is like. Now, Venera 7, and this is from the Soviet Union, actually made it down to the surface of Venus. Find that it only lasted for about 45 minutes because the surface of Venus is incredibly hot. Also, the pressures there are about 90 times what we have here on the Earth, so it is not one of those paradise places that we thought, 100, 150 years ago. Hopefully you guys will recognize this one as the Earth. This is taken from the moon. Probably one of my more favorite shots of the Earth. Kind of looks like that blue marble that's sitting out in space. And this shot is taken from one of the flybys that is headed out to the outer parts of our solar system, looking back and getting a shot both of the moon and of the Earth. And notice they are in the same phases. And we call our planet Earth, but yet when you look at it, you see mostly blue, which is what the water is, and then the nice white of the clouds, and some of that brown, which we know is the landmass. Just another picture of the Earth with the sun rising. Now we jumped out to Mars, and I'm not going to spend too much time talking about the sizes. We'll get into that a little bit more when we talk about the actual solar system, but Mars is about a fourth of the size that we are. Okay, so we're looking at Mars, and Mars has polar caps just like what the Earth does, only instead of being made out of water ice, they're basically carbon dioxide ice with some water ice that's there. Now, Mars has a big, huge tectonic crack on it that makes our little Grand Canyon look like a small little tributary. So imagine our Grand Canyon going from New York all the way to Los Angeles. And that's what you're looking at right here with this tectonic crack, or the Valley of the Mariners on Mars. And so we're going to talk about why, even though Mars is a much smaller planet than we are, why do we have these really large geological features on there, and what's going on? We also know Mars has volcanoes. In fact, guys, if you think about the size of Missouri, and you put that volcano right about where Missouri is, it would completely cover the state of Missouri. Very, very large geological features compared to what the Earth has. And there's certainly a reason for that, which we'll talk about a little bit later. We know Mars has frost and has clouds. We also know at one time Mars had running water and probably still has running water now. We don't see it very often, but we think we have at least seen it a couple of times. So indeed, Mars does seem to have water on it. And remember I said that we've seen it very shortly? Well, this is one place that we think we're looking at running water on Mars. Didn't last very long before it went ahead and froze and evaporated back. But at least we do see evidence of running water on there now. Now, we have been to Mars, and we certainly maintain rovers on Mars that are very actively sending back information, sending back data. And so this is a picture of the surface of Mars. Notice when you look out, it doesn't really seem all that different to what the desert would be like in, someplace out here in the Sahara Desert or something like that. That's one of the rovers that's on Mars. just an outcrop of rocks that are on Mars. You don't really have a good feel for how far away that horizon is because we don't have anything in there that gives us any kind of size. Now, we've also been able to collect meteorites from Mars. I know this kind of looks like just a big rock, doesn't it? But this was collected from the Antarctic here on the Earth. I know it's from Mars because when they cut it apart, the gases that escaped are the same kinds of gases that are found in the atmosphere of Mars. But yet when they cut it apart, that's what they saw. So what's going on there? Is that a natural formation? Is that kind of something, microbial life? Exactly what? So Mars certainly has some interesting possibilities that we'll talk about when we talk about the solar system. Now, for those of you that are a little bit older than what the normal college student is, you might remember when Orson Welles did the War of the Worlds, scared everybody to death because Mars was invading the Earth. And so when we get to Mars, guys, we'll go ahead and actually play you a little bit of part of what the dramatization of the War of the Worlds was like and talk about why it made such an impact on people, because there were some people that really did think we were being invaded by Mars. So what you see right now is Jupiter. And Jupiter is the largest planet in our solar system. And you see one of its moons right now being eclipsed. And that's a little black dot that you see right there in front of it. We find that Jupiter will have bands, and that's what you see in those light and dark areas that are going across Jupiter. We rotate once every, okay guys, if I ask you how long it takes us to rotate on our axis, what would you tell me? Well, hopefully you're going to tell me about 24 hours. Well, Jupiter rotates on its axis once in less than 10 hours, even though it's much, much larger than we are. And so we'll talk about exactly why that would occur and what makes Jupiter a gas planet as opposed to the Earth, which is a terrestrial planet, which means we have a solid surface. Jupiter doesn't. And the next 4 planets, Jupiter, Saturn, Uranus, and Neptune, are all gas giants. Okay, this is a much better picture of Jupiter. Brings out those bands a little bit better. This is taken by one of the flybys that went by Jupiter. And right there in kind of the lower center part, you see this great big red spot. Well, that's a big red cyclonic storm, and that storm has been there since Galileo first observed Jupiter about 400 years ago. Okay, think about what our cyclonic storms are here on the Earth. Probably the same type of mechanism, just adjusted for the fact that you have an incredibly amount of intense heat as well as the rotational effects that we see on Jupiter. And we see some little white ovals there that are storms that'll come and go, but that red spot has been there for a while. And just to give you a feel for size, guys, that red spot, someplace between 1.5 to 2 times the size of the Earth. Not our moon, it's the size of the Earth. Just another picture of Jupiter showing the auroras, like our northern and southern lights. Well, they also occur on Jupiter, as well as Saturn, Uranus, and Neptune. So the kinds of things that we see here on the Earth, we also see out within our solar system. So we will spend a great deal of time talking about our Earth and then being able to compare it with what we see out within our solar system. And now, with Kepler up looking for planets, exoplanets, and we have found at this point something like in excess of 1,200 exoplanets out there, talk about the same kinds of characteristics that we see on our planets within our solar systems and be able to compare it to the planets that we are finding out there, wherever there might be. Another close-up picture of Jupiter. Only this time, guys, you'll see that nice little black area right down there below that. Well, that's what happened when Jupiter got hit by a comet. Shoemaker-Levy comet broke up into several little strings of little comet sections and ran into the surface of Jupiter or that atmosphere of Jupiter and put some major holes in it. And luckily we were able to watch real time while that was happening. And so we do know that comets do run into planets. The question is, have they ever done that on the Earth? Well, the answer is they might have. And so we'll look at the evidence and see if we can find out where on the Earth that might have happened. Jupiter has rings just like Saturn, something that we were kind of surprised about. Saturn's rings are very, very visible from the Earth. Jupiter's, Uranus, and Neptune's were not. But now that we have been out there and have flown by those planets, we do know they exist. No, that's not a picture of a lizard. That happens to be a picture of the radiations given off by Jupiter. And so we'll talk about why Jupiter gives off so much radiation and how that then affects its little moons, and what implication that has for the other gas giants that we might find out there. Now, Jupiter has 4 moons. In terms of the 4 big moons, it actually has a huge number of smaller moons. But Galileo, when he first looked at Jupiter, saw 4 moons, which he named the moons of Galileo. And the first one, the one that's closest to Jupiter, is called Io. And the reason that I have this picture of Io on there is to show you that it's an extremely active moon. In fact, it's some of the most active solar system, or active real estate in the solar system, because it's got active volcanoes going on. Lots and lots of active volcanoes. And so what you're seeing there are this lava that is coming up to the surface that is oozing out. And those black areas are areas that the lava has cooled off. So we see volcanoes and lava production on Io in a huge amount of the time. Then we have Europa, which is basically having a surface of ice that covers it, but we think underneath it is probably a nice warm ocean. So what kind of implications does that have for finding life out at Europa, someplace different than on the Earth or one of the other planets? So the moons have all kinds of possibilities as well. Okay, this is the largest moon in our solar system, which is one of the 4 Galilean moons. Saturn is probably the most gorgeous planet that you ever see through a telescope. And the fact that it's got rings, very, very light butterscotch colors is coming across. Now, this is not taken from the Earth. This is taken by one of the flybys. This is Cassini that's out there by Saturn. And so you're getting a much better vision of the rings of Saturn. And you're seeing the sun, which is coming in on the left side, so you're seeing the shadow of Saturn on then the right side. Very different version of the planet right here. They are artificially eclipsing that planet then to go ahead and give you a feel for what the rings look like and trying to bring out some details of the rings. Just more details of the rings. Obviously, they're not really colored that way. Those colors are there to go ahead and bring out some of the structure as well as the size. We do know that Saturn does have different kinds of storms on it, just like what Jupiter does. This one happens to be nicknamed the Dragon Storm. It tends to look like a dragon. Now, this is something that's weird about Saturn. Having one of our flybys out there, they've been able to take some really close pictures of Saturn, and for some reason Saturn has this really strange formation of clouds at the very top. And so when we get to Saturn and start talking about this, I do have a time-lapse photograph of this where it'll show you the video and show you the rotational effects of this cloud. Exactly what's going on there, we're not really sure. We do know Saturn has a moon called Titan, and Titan does have its own atmosphere. So what kind of implications does that have if Titan has its own atmosphere? It is one of the only moons that has an atmosphere in the solar system. Then we've got Uranus and Neptune. Notice the little rings there. We know that they also have additionally, just like clouds that we have here on the Earth, they also have storms. This is a small little cyclonic storm. You know, they have cirrus clouds that are in the top that we can go ahead and observe from the Earth. So lots of different characteristics of the outer giants that we will compare back to what's going on within the Earth and see what happens. Now, we also have comets. Now, this is from when Halley's Comet came by during the early 1900s, and some of the advertisement that went along with having Halley coming around. Now, that doesn't look real impressive yet, but you see right in the center kind of that greenish blob, well, that's the comet. And as it gets closer and closer and closer to our sun, then it'll go ahead and develop a tail. So it looks something like that. And if conditions are right, then you'll be able to see that comet then during either the early evening or depending on when that comet will be visible. If you ever have a chance or you know that one of them is out there, definitely you want to take a chance to go see it. They're certainly worth it. Now, this is Halley's Comet, or at least the nucleus of Halley's Comet that we visited when we were heading out to the outer parts of the solar system. And so it's basically a big rock, kind of an ice-covered rock there. And as it gets closer to the sun, it goes ahead and heats up, and therefore you're getting material that is being outgassed, and that's what you're seeing there. And that material that you see being outgassed then will eventually go ahead and form that tail of the comet. Now, this is a picture that is just taken as a picture. This is not taken through a telescope or anything else. This is Hale-Bopp, and so all you had to do is look up to see this one. And a lot of people, unfortunately, didn't take advantage of the fact that it was here, and a lot of people missed it. But all you needed to do was go outside and look up. And you saw this incredible comet with these two tails. One of them is called a gas tail. The other one is an ion tail. And it looked just that bright in the sky. Now, I'm going to take a major leap here and go from the solar system out to looking at the rest of our galaxy and looking at all the stars as well as the gas and dust that's out there. Remember, I just said that the tail, one of the tails of Hale-Bopp was made out of gas, and the other one is made out of ions. Well, we know that there's lots and lots and lots of gas out there. And this is a gas cloud that's out within the spiral arms of our galaxy. And so I've just got a few clouds here a few pictures that I want to show you of those gas clouds. And notice the color. Notice how bright they are. And then as you look at there, the stars that you see in the background are stars within our galaxy. And our galaxy is a collection of billions of stars. We happen to be a spiral galaxy, and I'll show you what that looks like here in just a minute. But think about all that gas and dust that you have to keep going ahead and clearing and dusting out of your house. Same kinds of things that we're talking about out in space. Only out in space, they have lots of energy behind them and really, really beautiful colors. We're going to find out that these gas clouds then are what form stars. In fact, you're looking at the birthplace of a couple of stars right now. It's called the Eagle Nebula, and right at the very top of those towers are where we find new stars. And what you have here are two pictures or videos of two stars that are in a process of forming. The one on the right is doing what it's supposed to. The one on the left, unfortunately, is in the process of blowing itself apart. We'll talk about why the one on the right is behaving itself, the one on the left isn't, in terms of the mechanisms that are forming when we talk about stars. Now, this is probably one of the more common constellations. Hopefully you recognize this as the constellation Orion. If you're taking this class during the late part of the fall or early part of the spring, then you should be able to see Orion without any problems because it's a major winter constellation. See, there's a bright red star in the upper left. It's Betelgeuse. You see there's a bright blue star on the lower right. That's Rigel. Then we have the three stars that make the hunter, and that's what Orion is. He's a hunter, that make his belt. And then there's a sword that Orion is holding. And right in the middle of that sword, you're going to see a star that looks kind of fuzzy. And that's actually the Orion Nebula. There's more pictures of the stars that we have out in our galaxies. I want you to notice the color. And that color will be an indication of the temperature of the star, as well as where it is in its evolutionary sequence. All those stars that you see are stars within our galaxy. Now, this is a very new star cluster. In fact, it's so new, you still see some of the gas and dust that's left over after it formed. And you can see this very easily if you go outside and look up. This happens to be the Pleiades. It's a very easily recognizable star cluster. If you find Orion, and then you go a little bit on over, you'll find Taurus the Bull, and then up from Taurus the Bull, you'll find the Pleiades. Another little star cluster, as well as you'll notice over on the left, you've got some nebulous material. In this case, it's looking at a very blue color. And remember, that's dependent upon both the temperature, the material that it's made out of, as well as the stars that are around there. That's just a star cluster. And a star cluster are stars that are rotating around their common center of mass. And there's some very famous ones out there that we'll look at. Talk about how they all manage to be rotating around their own common center of mass. Now this, on the other hand, is what's called a globular cluster. Look at those. You get kind of yellowish, reddish stars through there. They're very prominent when you have a chance to see them. Unfortunately, you need either a really good pair of binoculars or a small telescope to be able to see these. And that's looking at actually one of the first pictures where we've actually gotten some really good detail on a star. And we'll come back and talk about this star, which happens to be Betelgeuse, one of those bright red stars in Orion, and how we think that it's probably in the process of getting ready to go through its last evolutionary phase and possibly blow up. So what's going to happen when that star blows up? And this is a star that has blown up. So it's definitely toward the end of its evolutionary sequence. And then that gas and dust spreads out throughout the rest of the galaxy, and from that we have new stars that are formed. Now when stars blow up, they do so with sometimes some really cool patterns. We'll talk about what's going on with these stars and what they're doing as they're ending their lifetime, compared to that star that just blew itself apart. And as you'll see, some incredible colors, as well as different stars that are forming different characteristic patterns as they go ahead and end their lifetime. And from that material, we have new stars that are going to form. See that big bubble down there? That's from a star that kind of blew up. And as it blew up, it sent its gas out then, kind of like a big gas bubble heading out through space. And that gas bubble will go ahead, if it runs into other clouds, be able to start compressing them down to go ahead and form new stars. And it's a big black cloud in space. Very cold, very dark. Now, why did I put that there? Well, guys, because we're going to find out that also every one of the elements that we talk about, the elements that make us up, the elements that we go mine for, the elements that make up everything in the universe come from those explosions that are created when stars go ahead and end their lifetime. So not only are you made of star stuff, but hey, so is all that gold. So every one of these we have seen new stars that have formed. So the cycle of life, not only in us, as well as the stars, continues over and over and over again. It's just that their lifetimes are much, much longer than what ours is. Now what I'm going to do is gradually get out of our solar system. So we've gone from that to our galaxy. And now we're going to go from our galaxy to other galaxies that are out there. Now, like I said, we're a spiral galaxy. And this is, by the way, not us, because it's very hard to take a picture of us because we're inside of it. But we do see all kinds of other examples of galaxies out there. And so we're a spiral. You have that bright nebulous in there, and then you have the spiral arms that are coming around the outside. So this is just one example of a spiral. And these galaxies are made up of billions of stars. For those of you who remember Carl Sagan, billions and billions of stars out there? Well, that's certainly true. This one happens to be Andromeda, which happens to be the closest galaxy to us as far as the really big galaxies. And eventually, the two of us, Milky Way and Andromeda, will run into each other. But it's a spiral like what we are. It's about twice as big as what we are. This happens to be an elliptical galaxy. So we know there are spiral galaxies, elliptical galaxies, and irregular galaxies. Just the various galaxies that you'll have out there. What you're seeing across that one is you're seeing the gas and dust bands. So think of spiral arms seeing edge on, and you're seeing the gas and dust there. Now these are two galaxies that are going through each other. This is called the Owl Nebula, or the Owl Galaxies. Looks like kind of the eyes of an owl as it looks towards you. But in reality, it's two galaxies that are going through each other. So we'll talk about what happens. What happens when the Andromeda goes through us? Will we notice it? Will we get stars running into each other? Well, we're going to find out that there's so much space in there that, probably never have any stars running into us. But what will happen is all the gas and dust in those two galaxies will kind of have problems. They don't really exactly know which galaxy to go with. So a lot of times we find that they're just kind of left right there in the middle as the two galaxies move away. And so what that gas and dust that's left we'll have a tendency to form new stars and evolve into something else. Now we also know there's clusters of galaxies out there. If you notice this picture, there are some points of light in here that have points on them, that really do have points on there. Those are the stars. Okay? Everything else in there that you see is a galaxy. And so we know there's clusters of galaxies out there. We know there's clusters of galaxies out there. Now if I look at this picture, with the exception of one or two points of light in there that actually have the little points which are formed from overexposure within the telescope itself, everything that you see in that picture happens to be a galaxy. This is the Hubble Deep Field taken with a Hubble telescope. And so guys, I want you to imagine yourself looking up, and this is the amount of sky that you're looking at if you hold a grain of sand at arm's length. So think about what a grain of sand is like. I want you to hold that at arm's length, and the amount of sky that that grain of sand covers is what you're looking at right here with a Hubble Deep Field. Now guys, everything that you see in there, essentially, other than one or 2 points, is a galaxy, and every one of those galaxies are made up of billions and billions of stars. So it kind of puts you in a different perspective relative to what's really out there, and that's what we're going to spend the semester talking about. We're going to start with right here on the Earth, and we're going to head out to the outer edges of the cosmos. So with that, guys, I will plan on then talking to you in the next section. And please make sure that you check Blackboard, because I'll have an assignment on there in terms of the reading that I want you to do, and a couple of questions to help you get started looking at what's out there. See you later, guys.